Okay, it's not doing it now, so I guess we're okay. Okay, that's half. I need 5 more. Sweet Lord. Don't make me call you. Can you guys get the lights back on real quick? I want to get at that word average. Right. What do we got? What do we got? We got. Okay. We got Patrick, Andrea. We got Madeline. We got John. Wait a minute. You have the same birthday as this guy over here.
No, same.
No.
Same as me.
Yeah,
Same. It was Madeline's birthday.
Remember, there's extra letters.
Just extra letters.
Yes. Christina.
Oh, Christina with the E-A-N-A. That's it, Christina. Good, good. Christina, I just asked your name earlier, and I've already forgotten it.
Stacy.
Stacy, thank you. That's Roxy. Roxy. Okay, good. This is Danielle, or Danny, and this is Luanda. Okay, we're getting there. Slide down this way, guys. Patrick, these are for you. Don't eat them yet.
Thank you.
Yes. Madeline, just put your hands out. There you go. Those are yours. And once I dump them into your hands, if you guys would be so kind to kind of hold them up so everybody can see how many you've got.
Play your favorite. I got a lot.
There you go. Christina, since I forgot your name, you get all that chunk. All right. Stacy. Here you go. And then we've got 2 more, right? All right, Danielle. Yeah, hold tight, hold tight. All right. So you guys, hold them up nice and high. So, okay, good. I want to get at that word average that was used. And somebody back here, it might have been Roxy, you might have picked on it earlier when you said, what is the average family or average American? I love that. I want to get at that word average. How many of you have heard that term before? Average. Yes, most of us have heard what an average is. How many of you have taken an average before? Of course. Very, very good. Very, very good. We all know the formula for average. Here's what I want us to do today. There are 10 people in front of us. I lied to you, there are 9 people in front of us. Get 1 more person up there. And because you waited so long, you don't get any. Oh, what the hell? I'll go up there myself. All right. 10 of us, and I'll get the lollipops. I want to know this. On average, can you see all of us in that camera? Are we all kind of visible? No. Ish, not really. Let's get closer. Get friendly. Get friendly. How we doing? Yes. The one thing I told you would never happen. You would never be on camera. Lying SOB that I am. You'll never be on camera except for that one time. I want to know, on average, how many lollipops we have. And you're not allowed to use the formula that you all know and have been using since you were in 2nd grade. So, since you're not allowed to use the formula, and you know the formula is, right? What's the formula for average? Go ahead and verbalize it. Add them all up and divide by how many we got. There's 10 of us, right? We divide by 10. Not allowed to use it, but I still want to know how many on average we've got. And the reason I won't let you use the formula is because I want you to develop the formula on your own using this exercise. So, audience can kick in too if you have any ideas of how we can figure this out. I have a vote for 4. We have a vote for Renee, thank you. 4, good. Anybody? 2?
I'm going to say 3.
Say 3. Good. We've heard of 2, we've heard of 3, we've heard of 4. Good. This is one of those things that actually has a number answer. Like this would be a good test question in class. Give you the lollipop pictures and say on average how many we got. Because there is one numerical answer to how many lollipops on average we have. But what I want to get at is, what does that number even mean? What does it mean to have an average number of lollipops per person? What would that imply about that value, whether it's 2 or 3 or 4? What would that mean? Suppose it's 4. Suppose it's 4. What does it mean to have an average of 4 lollipops per person?
About 4.
Everyone, what I just squeezed very hard, I'm sorry, Patrick. Total squeeze, I apologize, very excited. He's a rugby player, he can handle it. Lawsuit on camera, right? Nice knowing you guys, it's been really fun for we can handle it. On average, everyone would have 4. Now, some of these people have 7 and 8, and I don't have any. But what are you saying? What are you implying? I love what you're implying. Say it again, say it again.
That everybody would have 4?
Okay, if what was true, let's go with what Patrick's saying, or 2 or 3, depending on what number it is, and I'm not sure what number it is yet. So you hear what Patrick's saying? All of us would have 4, or 3, or 2.
They're all distributed among everybody.
That's what you guys are thinking. Tell me your name again.
Andrew.
Angie, thank you. If they were distributed equally among all the people. I think we know what to do, friends. Go! Let's distribute.
Please.
Let's distribute. Patrick's giving me 2. What a doll. That's total good love right
I've
there.
got 4. You've got 4.
I got 2.
Okay.
John's got 3.
I got 3.
You got 3, so you should give him 1.
And you should give
Okay.
him 1.
How we doing down there? How we doing?
Oh, yeah.
You got 4, Madeline?
I got 4.
I think if I did the math right, I did this nicely.
3?
I've got 3.
I got 3.
We got 3, 3, 3, 3, 3. On average, we have 3 lollipops. Patrick nailed the conceptual definition perfectly. If we had the same number as a collective group, but it was spread out evenly amongst the group, that's what the average is. Now do you see why the formula works? What is the formula? First thing the formula does?
Adds everything up.
Adds them all together, which means we throw all of them into a big old pile, and then we do what with the pile? We distribute it evenly amongst the 10. Dividing by 10 means we make 10 equal-sized piles. Boom, there's your average. That's why the formula works. How many of you have ever heard it explained that way? Julie Keener explained it to me 10 years ago. My jaw hit the floor audibly. I needed surgery. It was amazing. I'm like, oh my God, it makes sense now. Now I see why you add and divide. It's a share. Beautiful. Friends, you've been awesome. Have a seat. Who wants some sugar? Don't want some sugar. There we go. Spread it around. Spread it around if you guys want. Or just drop it back in the pile. It's fine too if you don't want sugar.
Anybody?
Good. Yes. Yes. You guys have been fantastic.
What a dum-dum.
Food, sugar? Guess it's not late enough in the day yet. Okay, thank you, Madeline. All right, let's chit-chat about this. Okay. Now that you know why the formula works, please use it at all times. Okay? Please, don't ever not use it. I just wanted it for that one point. Because I wanted to make sure you guys could derive why it actually makes sense. The idea of today. We're recording, right? We're good? Good. Thank you, Daniel. The idea of today's lesson, and this is going to stretch into Wednesday, definitely, is measures of, I'm going to put it in quotes, center. My goal in this course is not to teach it like a traditional statistics course. And that means I don't want to fill your head with formulas and have you regurgitate numbers out. Well, that's okay. That's okay. And the problem with teaching statistics only as formula is that eventually you'll get so tired and so burnt out on memorizing the formulas you'll forget what they're actually telling you to do. I'm not saying formulas are bad. They're wonderful. There's a reason we have them. There's a reason the average formula is so popular. A, it's easy, and B, it's indicative of something, which we're getting to. But we'll try to use only the ones that we need to use that can't be replaced by something that's better. And honestly, I think I've gotten the course down to 3 or 4 of them. One of which we'll get today. That we'll use quite a bit. And that'll be replaced by technology, hopefully come Wednesday. We'll see how time goes. There are many measures of, I'm going to put center in quotes right now, only because I don't want to define it right now. But the idea of the center of a data set is to take a bunch of data points and use one number to stand for the center of that set. We did it earlier today, do you remember? When we had that beautiful graph on the board with the different, and I said, so what is the average perceived income of a middle class person? And I made you pull a number out of that. You were pulling the center out of that data. Nobody guessed the far right tail or the far left tail. You guys were kind of going back and forth around the middle and saying, I think it's somewhere here. You were centering the data set. And there is more than one way of centering a data set. I want to talk about 3. There are at least a dozen that I've heard of over the years. I don't want to do a dozen because 3 get used the most. Any of the other ones you'll get to eventually, and we'll get around to that. So the first up is the one you just kind of discovered something about, is the average. The average. Now, if you had to pick a word to imply what the average does, I mean, center is a good word. It's a fine word. But if you had to pick another word that you would use to kind of stand for what an average is, what word would you use based on what we just did? The median? Can I save that one? Because the median actually points to a different center sometimes. No. It can put the mean. That's actually another word for this average we're talking about. Very nice, Christina, yes. Sometimes it's more technically called the arithmetic mean because you're adding and dividing. There are other kinds of means. There's a harmonic mean, there's a geometric mean. They're all great and they're all very, very specific in their use. A non-mathematical word. What's something we just did in that calculation up here?
Distribute.
We distributed evenly, didn't we? Distribute total data equally. I love that. Give me something else. What else did we do? I love that. Thank you, John. It's perfect. Madeline.
We kind of democratized it.
Yes! Dare we say it was a socialist? Dare we say, we'll say democratically divided. It was socialism, wasn't it? I mean, come on. It totally was. We took the resources we had and split them equally. If we had a need for sucrose, we all met our needs equally. So we'll say democratically divided. Yep. I like that. What else? What did we think? I'm thinking like my 6-year-old. As soon as Patrick said, I forget how he said it. He said it perfectly, though.
It's not shared.
He shared. That's the word I was looking for. You shared. You shared it, right? It's the shared center. You shared, and you're sharing total resources. Again, you're sharing total resources. So you have a bunch of resources. You take from those who have more and give to those who have less, so that everybody. Say that again, John.
Robin Hood.
Robin Hood. Well, ish. Ish. Yeah, I guess it is kind of Robin Hood. Take from the rich, don't give to the poor. But the idea is you take a total data set and you break it down so that it's completely even across the board. Across the board. Cool? This gets used all the time in statistics. The idea of an average gets used all the time. So much so, it's got a special symbol. The special symbol is X bar. Put that over here. X bar. That's how you would read it. X with a little line over top of it. Okay? When you see X bar, that means you are taking an average of a sample of numbers. This is the average of a sample of numbers. And the way you do it, the formula is beautiful. It does work. I mean, I'm not trying to say that don't use the formula because it doesn't work. No, don't use the formula once because I wanted you to kind of explore it. The formula gets used so much, it also has shorthands attached to it. This is the Greek letter capital sigma. Whenever you see that mathematically, it means you're adding a bunch of stuff up. Sum, exactly. That's why they use sigma. I've noticed in mathematics, whenever we use Greek letters, we try to use one to start with the same letter that we're implying the mathematical operation on. So when you see a capital S, it means you're summing things. From geometry, pi, 3.14. Why the hell would you use pi? Because it's the first letter in the word perimeter. And the definition of pi is the perimeter of a circle, which we now call the circumference, divided by the diameter. So there's always a historical link between those letters that are used Greek and the mathematics behind it. So that's cool, sum. And you're summing up the data, and data are always just called x's. There's a difference between an x and an x bar. An x bar is a number that represents the sample average of the entire sample. Each little x is the individual data points. We'll come back to that momentarily. And then you would divide by n, which is your sample size. That's your sample size. So we'll put that in parentheses here. This is the sum of the data, and this is the sample size. That's the formula you've used all your life. Add them all up, divide by how many there are. That's it. That's just it in mathematical symbols. And as soon as you express it in mathematical symbols, you can do stuff with it, which is kind of nice. That's kind of helpful. That's kind of helpful. So, do you see this is what you would have done with the lollipops? Right? Sum of x. Each one of these x's is one of the numbers of lollipops you guys had in your hand. Every one of those x's. So for Madeline, it was like 7. 6. For Stacy, I think it was 3 or 4. For me, it was 0. For somebody else, it was 0 as well. I forget who now. For some people, it was 1, 2. The sum of all those together summed up to, although we never had to do it,
30.
But it did sum to 30, didn't it? We never actually had to sum it to 30 because we didn't use this formula. We went straight to that value. So this summed up to 30. This is why I kept saying there's 10 of us. I wanted you to do nicer math than nastier math. 30 divided by 3 gives you your 10. Is that fair? That's a sample mean. X
Wait,
bar.
30 divided by
10 gives you 3.
10 gives
Did I
you
say
3.
30
You
divided
said
by
it
3
reversed.
gives you 10?
Yeah.
Well, it's a correct mathematical statement that the meaningless though.
Yeah.
Yes, so 30 divided by 10 gives you 3. Thank you, Madeline, for fact-checking me. Sorry, YouTube world. So, all 12 of you. Let's be generous. All 2 of you. So this is a beautiful little, let's bring this down here. Let's put it right down here next to it. It's a beautiful little formula, a whole, it's arrow equals, it's all the same thing, it's all the same thing. So the idea of this, when you see this guy, it is a number that stands for one measure of center of a data set. I'm going to mention another one we'll come back to later in the course, and only because it does tie in here. There's also a population mean. It's called mu, the Greek letter mu, which looks kind of like a U with a long tail. Okay, you may have seen it before or heard it before. In physics, they use it for coefficient of friction. Mu is the population average. And we often want to know that, but we never can know that. Why?
because it's constantly changing.
Well, that's one very, very good reason. Depending on what it is, it's most likely constantly changing. And even if it was static, why couldn't we know it?
Too many.
There's too many, generally, in a population that go out and find. I mean, imagine wanting to know the average weight of an American. Holy crap. 310 million Americans? What about measure 310 million Americans? By the time I get to them, they're going to die. Then more are born, constantly changing. But even if I could flash freeze them, I couldn't pay somebody enough to measure 310 million Americans. Why? Why do I say things sometimes? I don't know. That's one. That's one of the measures of center. Fair enough? That's one of the measures of center. That's a classic. That's a classic. It's got issues which we'll deal with. We'll deal with the issues this sometimes has in line. Okay, good. Some other ones you may have heard of. One of you mentioned one earlier. I said, give me another word for average or mean.
Median.
Somebody said median. That's a beautiful one. One of my favorites, honestly. The median. Ugh. The median. What is the median if you remember it from previous classes? I'm expecting you not to. I mean, part of the course, this course is to learn what it is. But if you have heard it before, what is it? They use it in real estate all the time. Tiffany, thank you. There's a reason for that. We'll come back to that. Hold that thought. Thank you. What do you think? Oh, it's okay. You don't remember? Cindy, you remember ish?
Data point that's basically in the center.
Very good.
Middle value, but it doesn't have to do with the averages or actually distributing them. It's just the one that happens to be in the center.
Good. And there's one important thing we have to do first before we do that. If you look at, you got it, Christina. It's what I had to do in that Excel sheet when I was trying to figure out how many were in each. It's the middle data value after the data is arranged in order. And I don't care, write this first and then talk. I don't care if you arrange it in order up to down or down to up. The middle will be the middle. Doesn't matter to me. There we go. We're about as far back as we go. We're about as far back as we go. There we go. So it's in the middle. We're going to actually calculate some of these momentarily. But you got to get the data arranged in order first. I can't do the median for our lollipop data because I didn't write down how many I gave each of you guys. Two of us had 0. You did! Goodness. 0, 4, 1, 3. This is beautiful.
Way to go, Ann.
0, seriously, right? 0, 4, 1, 3, 7, 3, 6, 2, 4, 0. So in order, there's 10 data points. So it goes 0, 0, 1, 2, 3, 3. And I think then I've crossed past, and then 4, 6, 7. So, if my middle would be between the 5th and 6th points, which would be 0, 0, 1, 2, 3, 3. So 3. So technically, you take, there's no middle in a set of 10. There's halfway between 5 and 6. And that's what you would do. It just so happens both of these are the same. So we take 3. So our average and our median are the same number for lollipops. Thank you very much for that. Very nice. Thank you. Much appreciated. Yes. Yes. Good. 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 And the last one I want to talk about, which looks like we have at least one on your data there, which is beautiful, is the mode. Good. Some of you have heard that before. Good. Your mode. Your mode or your modal value. Your mode or your modal value. If you've heard of the mode before, what is it?
Remember that.
Perfect. I'm gonna. I had a 244 drop this on me beginning of class. It's the mostest. I apparently said that last year at some point in 243, and my whole pack of 244 students brought it back to class with me. It's the data point that occurs the most. And there could be more than one. The data point or points that occur the most. For our lollipops, it sounds like there's 3 and 4.
3 and 4.
Because there are 2 3s and there are 2 4s. So we're going to call a mode, it's bimodal in that respect. It's a very small data point, their data set, so not, and it's lollipops, people don't care. But we have 2 modes, bimodal. If each one of us had a different number of lollipops, there wouldn't be a mode. There wouldn't be a mode because they'll all be different, they'll all be unique. As data sets get larger and larger and larger, modes inevitably occur. Okay? You might have remembered Tiffany said, when I said median, you said real estate. You went right to there. This is fantastic. Here's what I want us to do. Average, median, mode. I collected some data from you guys in class last time. And here it is. Let me find it. There it is. This is how many keys we had in class last class, Wednesday. I want you, please, be nice, please calculate the average, or the mean, the median, and the mode for that data set. And call it a sample. Call it a sample mean, sample median, sample mode. Take some time. Work with each other if you want to. Use the formula, please. Don't do the sharing thing with the keys. It's too annoying. Yeah.
Are you saying for our
Use you
class?
guys. Yeah. You can ignore the Tuesday, Thursday. I put it on the same slide. You guys just do your class Monday, Wednesday. Okay? I'll turn the camera off, save some battery, and then we'll come back.